Okay, day 21. Let's put more stuff into the build program. Alright. What's the next thing? Well, data.bin should probably move into the build directory. So let's do that. Build. The build, yeah, we always have the build directory, we don't need to create it. And let me just remove it from here. Alright. So now it goes into the build. Now let me just go in here. Is that like... yeah. Alright, where data, okay, so this needs to change to build, except that I want to load it relative to the executable, ideally. So, well, for now I'm not doing that. It's just data, build data.bin, alright, let's compile that. So it's written out there, and I should probably name it that. Oops. Yeah. And maybe now actually let's call it, well, that. Let's call it that. Yeah, there you go. That works. So this would be that. Okay, still works. It still works. Now, so this is fine. But this right here, I think it's the only file we are reading now. Yeah, it's the only file we are reading. I don't want the game to care about what working directory it's running in, so this should be just be loaded relative to the executable. And I think we can get that. We can get the path to the executable easily enough. Maybe. Alright, I think there is an API called MSDN. Oh my god, MSDN. Get executable path. Oh, get module file name. Get module file name. Fully qualified path that contains the specified module. Well, let's try that. H module. I think that's just that instance. And then this is out. This is the out string. Alright. And is that null terminated or what? Okay, so it's all sorts of different. Yeah. Well, char star exit path is arena free pointer memory scratch. Memory block, memory scratch. Alright, so we get the path into the scratch space. Then we go in and say exit path, and then this is size is arena free size, memory scratch, memory, and it returns the amount of the length of the string that is copied to the buffer in characters, not including the terminating character. D word exit path length is that. Memory scratch used plus equals exit path length. Okay, so that is the path and that is the length of the path, and let's see if that actually does it. Let's compile. Yeah, that is what we want, yeah. Alright. Now, we can just construct, it's the same path except the last three characters are different. So, char star data path is exit path. I mean, I can even do something like this, right? Data path is 0, and we just go in here, we run that, we say exit path length -1, well, -3, 2, 1, like that, D, A, T. And then data path equals exit path, like that. Well, we can even make it a string. Data path is exit path length, like that. So we read entire file, data path like that. Okay, so that works. Okay, so now it's loaded relative to the executable, so we should be able to launch the game from anywhere, like here. Yeah, that works. Okay, because now the working directory doesn't matter. The only thing is, what if there is a special character in the path? What happens then? Yeah, we kind of want to create a special character. So let's create a special character. Why not? And let's put an emoji in there. Specifically, I want the Unicode of that. Which one of these is copy pastable? Is that copy pastable? Yeah. Okay, what happens here? I mean, well, let's just try launching it. Like, build that, yeah. Yeah, it fails. Okay, well, perhaps we can make it work though, if we just do get file name W. So now exapath can be, well, it's a U16. Well, wchar t, I think, technically. Is the length in characters? In tchars, yeah, it's in characters. It's arena free size of, what's that? Okay, so used is that times size of this. Okay. So this is length in characters. Okay, well, we can't really use read entire file A in that case. We have to use the W version of that. So we're gonna have to basically inline it. And do a different version of all of this. Yeah. Yeah, okay. Alright, so there's the data path. So that data path is not a string because that's not wide. So it's gonna have to be this. Just null terminated. And just make sure that the last one is actually 0. Like that. Okay, so exapath lang in chars. Exapath lang in chars, yeah, that's fine. Then data path is exapath. Like that. So this doesn't happen anymore. So we open this H file. We don't do this because it's already null terminated, so that's not necessary. The stem block not necessary. Okay, handle H file, create file W. That's gonna be data path, generic read, file share, whatever. Yeah, that's fine. Assert, well, if we can't read the assets, then we can't run the game, so yeah, assert. File size, get file size X. Hopefully, yeah, this one doesn't matter if it's W or whatever. Assert, yeah, well, again, if we can't read, we can't read. File content, alloc array, memory, perm, bytes read 0, read file result, read file, assert, close handle, okay, well, hold on, is there, oh yeah, alloc array, that's what did it, okay. So we read it into there, assert, close handle. Now U8 array, we don't really need that, I don't think. Assert bytes read is size of asset data. asset data. There we go. Now we can cast file content. Actually, it's at this point that we can assert that file size quad part is size of asset data. Just make sure it's the right file. Then file content, this could just be asset data. And now I can just do asset data 1, like that. I want one of these. Bytes read, read file result right in there. This is how many we want to read. We already asserted it's the same. Assert close, and then call after load. Yeah, so that does make sense to me. Are we still running or what? Oh yeah, we don't have the... We don't have this stuff in the... So this needs to be replaced with that. And in the build program... Oh yeah, this is just not gonna work, huh? That is not gonna work. The assets aren't changing though, so let's just not worry about that part. The linker is incapable of handling this. So, okay, well, never mind then. I guess I'll just have to rename it to recompile. Okay, now it's recompiled correctly. Does it run when there are no special characters? Yes. Does it run from a different directory? No. Yes. What if there are special characters? So let's copy this. Let's go to here. Let's rename it. Well, we can't really F5, but we could do this. Ah, that runs. Perfect. There we go. Okay, so we can handle emojis and special characters in the path, in the game. Not in the build program, but in the game we can. Is that it? Let's see. Yeah. Oh, actually, this also means that we're not calling this read entire file is only called in the build program. It's not actually, it only handles ASCII paths. Which means we don't really need to include this here, except for the assert HR. But like, oops. Include windows, define asserts, then include common. And then in common, we're just not going to do this at all. There's going to be no platform. Here we've got assert HR, which is now not defined anywhere. So include, let's see, generated common. Yeah, okay, so that assert needs to be defined here, and also this needs to be included, like that. Alright, so now platform is not uncommon. Also, we don't need this struct at all. There we go. Yeah, that's fine. The entire file moved here. Did those two to-dos, wrote out the build where it's supposed to be, removed platform from common. Alright. Load assets relative to executable. Alright. So we got this one. Move everything in build.bat. Well, the only other thing that's in build.bat is this thing. Yeah, why not? Let's move it in. Since we already have the build program anyway, might as well. And that'll be all. So yeah, ideally we'll just invoke line as an executable, as a library, I guess. But like, for now, let's just create a process that does that. Alright. So what do we need to construct this thing? We need, well, the main file is always going to be the same, so we're not going to change that. So this argument doesn't change, this doesn't change, that doesn't change. We're only doing debug builds, so that doesn't change either. the output name doesn't change, so yeah, really there's no reason to do much here. For now. So that's the command. Now we need to execute the command, which I think is create process or something. So all this stuff, yeah. Create process, oh, what is this? Launch for create process. That works, create process, oh boy. Create process result. Create process A. Application name. Command line. Okay, so that, alright. In optional application name. Command line. The command line to be, I think you can skip this. It can be null. Yeah. So, no application name, that's the command. Security attributes. Optional. Thread attributes. Create pipe. Security, do we need any of this? No. What's next? Thread attributes. Again, security attributes. Yeah, we don't really care about those. Inherit handles. Yes. True. Creation flags. Process creation flags. Well, no, not really. I don't want any of these. This parameter also controls the new process priority class. Okay, oh, it can be 0, yeah, well. Environment. Nope. Current directory. Nope. Startup info. Okay, well, startup info. We have to create that. Process information. That's out. Yeah, alright, so startup info. Is that a real thing? W? W? No. Okay, what's in startup info? I'm guessing size. Yeah. Size of that. Reserved desktop. Title. Size. Fill. Flags. Standard input, standard alpha, standard error. Do we need startup info? No, we do. Evidently. Yeah, let's just, what if I just don't have anything there? Process information. Yeah. Proc info. Create process, what does it return? You can just assert that. That. So that's not really necessary anymore. There. So now it's one line. Okay. Yeah, I don't really know what this is gonna... Get exit code. So now we kind of have to wait. So process information has something for us to wait on. Process hthread, process ID, thread ID. I think it's wait for single object. Single object MSDN. Handle and milliseconds. Infinite. Yeah. Wait for single object. Handle is proc info h process. Milliseconds is infinite, not infinity. Now those are different. It's infinite specifically, which is that. Infinity is actually a different thing. Yeah. Okay, what does wait for single object return? Well, it can't be, like, we kind of want this one, right? We want the result to be that. Does that work? Yes. Remarks. Well, now we need exit code. Get exit code or something. Get exit code. H process, and that's the out. Alright, exit code. What does it? Bool. Get exit code process. Well, it's not a thing that exists. What are you talking about? Include windows.h. Get exit code process. And what? Wait, it's this process. Exit code. A D word. Assert on this. What does it return? Succeeds is non-zero. Okay. So now we know the exit code. We need to assert that the exit code is 0. Okay, does that work? Maybe. Okay, so it failed here. Okay, exit code is not 0. Yeah, so that actually does make sense. Yeah. Well, looks like we can run fine. Let's just add a few status messages. Yeah, no, shady compilation happens very quickly. Well, I suppose I can add a message at the end that says how long everything took. Just doesn't seem really all that necessary. Yeah, so that clearly takes a noticeable amount of time. Compiling, okay, finished in what is it, like 2G? And this is gonna be get milliseconds from program start. So right at the beginning we can do query performance counter. And I don't really want to do that every time, so hold on, let's just section sprite section misc. Performance counter. Is it large integer? And build program start like that. So query it. And, well, we also want the frequency. Performance, frequency, query performance, frequency. Frequency. Okay, So query counter, query frequency, that's per second, right? And then F32 static, F32 get milliseconds from. Oops. Let's put it up here, I guess. And this is going to be a large integer counter frequency. Alright, so diff is going to be count, well, okay. So that is going to be as function static u64 get clock u64 clock before, I guess. So now is get clock now is get clock u64 diff is now minus before, and then F32, sure, I mean it's not a high precision operation, so it's fine. F32 ms would be F32 diff divided by F32 frig quad part. Return ms. U64 build program start is get clock okay, so we get the clock, then there's the frequency, then down here frequency per second. Yeah, so that is frequency per second. So this is actually giving us seconds. And we want milliseconds, so something like that. Um, 334 milliseconds, so the whole thing takes 334 milliseconds. So whatever delay we are noticing here is likely due to compiling the actual build program, which we're not timing, and invoking that, and also invoking the script. And also there is a delay after the process task terminates in VS Code. There is a delay before VS Code realizes it terminated. Okay, but the actual build program takes no time at all, so that's fine. So now, okay, we don't have anything here. can I, like, do that? Yeah, I can. There we go, now it's one line. Yeah. I guess that's fine. Yeah, right. So now everything is in the build program. Move everything to the build program. Yeah, that works. To do. Subtract base here. Oh, yeah. Okay. Alright, so when we write out these arrays into the assets, in these arrays, the pointers in there are actually offsets. And it's probably whatever procedure that's writing them out that needs to make it so they are offsets. So modify them here. So what would that look like? What would that look like? Well, we know the pointer is the first element of... Well, the pointer is like... Okay, hold on. Yeah, that is the pointer to the arrays. And we know how many arrays there are and how big each array is. So, RL index is 0. RL index is less than R element count. RL index plus plus. So go through all the indices for the elements. Void star R putter would be R putter plus RL index times R element size. Yeah, just move the pointer forward. Okay, so now we have this pointer is pointing to the array element. And the first thing within that is a pointer to the actual internals of the array. So if I just modify it, like we know what the base is, right? Do we? Do we know what the base is? Well, the data is written out first. So yes, we do know what the base is. The base is just, it's like void star data base is data builder bin length well, that's not this database. Hold on, that's not this database. We want yeah, the array, the all data pointer. All data pointer is the base. Yeah, we're passing that in actually. So we want to do some kind of subtract from all data putter here. And just assign it, right? Like, sort of like that. Oh, yeah, something like that. So array pointer is, okay, you know what? Struct so move the pointer forward and then cast it as a pointer to this thing. Does that work? Does that work? Does this need another set of parentheses? Yeah. No. R type. R type, why not? Yeah, that's what I wanted to say. And then now this thing is the thing that I want to modify. Equals R footer minus base, which is so let's just cast it to U64, subtract all data footer, and then cast that to void star. Something like this. Make pointers in array elements be offsets from base of all data except it's offsets in elements. We want offsets specifically in elements, because we're setting the pointer to, so that's all data, which is a point, so there's going to be a multiply in there by the size of the element. It's kind of automatic. Yeah, so that's an offset in elements. Offsets in elements from the base of all data. Which means that it's this pointer minus this pointer actually divided by element size. All data element size. This is one awkward manipulation. Now anything that calls this, which is when we call it through here, yeah, these two things. Okay, both of them now need to have actual pointers. And while we are at it, we might as well assert that array pointer is greater or equal to all data pointer. Doesn't make sense otherwise. Okay, so both of these things now, animations, all animations, animations, right? So where that's filled, yeah, so that this right here is not void star animation durations length. It's actually all animations durations pointer plus animation duration length. And the other one, all shaders. So wherever shaders are filled, yeah. So it's not shaders data ling. It's actually all shaders data pointer plus all shaders data ling. Okay, that seems to have, yeah, so that seems to have worked. Okay, now we can dump arrays and not worry about doing this weird thing where the pointer is an offset, because that's generated now. The base is subtracted here and then added back in here. Alright. Node move pointers are offsets in elements from the base of all data. So move, so make them into actual pointers by adding the base of all data. What does this look like? Let's just step through that. Let's look at animations specifically. Okay, so all animation durations, there's only 4 of them. There's the animations, and this is actually pointing somewhere. So if we step into that, it'll go, well, now we have no idea what these types are. But we know array element size is 16 and data element size is 4. So like that is the array, and we only know the pointer, and this is the data pointer, right? So like array pointer becomes well, just 0 essentially. This next one, is that, and all data pointer is that. So no, wait, that's not this, it's specifically I want the splitter thing. Can we? No. Oh, because it's not. Jesus. Can't debug anything when it's internal. Yeah, that breakpoint can go away. Alright. What specifically what I want is R splitter minus all data splitter. Is this something we can do? Okay, so that's 0. The next one is 4, but element size is 4, so it's 1 in elements. Then it's 12, so that's 3. And that's 0 again. Then it's 3, 1, whatever. Element size actually 1, so that is the offset. Yeah, okay. Yeah, no, this seems to be working fine. Alright. Subtract the base of the array while writing it out. Something like that. Of course, this idea could be extended to just, well, you know, we could just have a big array down here and just have a bunch of pointers into it. And then we can have whatever pointer structure we want. Well, we still kind of need to go through it and fix up all the pointers. Yeah, maybe keep it this way for now. Right. What other to-dos did I have? Kill focus message, well, sure. We don't use the alt key, so we don't actually need to do that. Compress. Yeah, so this buffer is it's a vertex buffer. It's actually an instance buffer in this case. And these are the instances. Except that sprites are elsewhere. Screen rectangles are here, sprite rectangles are elsewhere. Here, apparently. So we'll allocate memory, we read the assets, then we allocate the sprites, then we create the window. Well, I mean, I guess by the same token, I can do that for screen rectangles, right? And maybe that just put that into game state. Input and miscellaneous, that's what I have, and platform. I see. Okay, type def struct game state. Oh, I guess just game, maybe, I don't know. So we have one of those for sprites. We have one of those for screen screen rectangles. I mean, there's nothing platform specific about that. So, yeah. C buffer, well, yeah. Screen rect. Screen rect. Sure, that works. I mean, this is really kind of a part of the game state. Sprite scale multiplier, and so is camera position. Like, it doesn't really make sense to update it in the buffer, like it makes sense to copy it from the game state. Window dimensions, well, that's a platform specific thing. Catalyst dimensions, well, those don't even change. They're just constantly like that. Yeah. So window dimension, this dimension, sprite scale multiplier, and padding. These two things are definitely part of the game state. Then in here, this can just be a buffer that we map and copy stuff to. This isn't here anymore. Which means that we might as well put this instance buffer inside of one of those. Maybe? Well, let's see. Yeah, okay, game state. Game state. Yeah, asset data, that's kind of, maybe just put that inside game state. The pointer to asset data. Well, arenas, anyone can use arenas, so that's not really. Assets, just put that inside, why not? Or maybe just call it game, even. Remove that. Game assets. Okay, so there's the memory, there's the game. Load the assets. Yeah, these should just go into the assets, camera position, screen rectangles, sprites. Yeah, so sprite scale multiplier can be set to like 2. Camera position is 0, screen rects, capacity can be set to something, and sprites capacity can also be set to something. Actually, do I even need to take it out? Or can I just inline define it? Yeah, and now this can be just down here. Might as well immediately allocate them, why not? So this is game sprites pointer, game sprites capacity. This is game screen rects pointer. Game screen rects capacity. There's the assets, and then it's onto the window. I mean, that works. Alright. Now we have this D3D11 thing. Rect, sprite, screen, so on. Rect screen storage. So rect sprite buffer is that. Okay, rect screen, but that's all we need. Device size of screen rect times game screen rect capacity. Game sprites capacity. Yeah, that works. Then, well, asset data is just game. Yeah, so this VSPS thing. Well, asset data is assets. Game assets. Atlas, yeah. C buffer. Well, yeah, this isn't really gonna happen here. So this is where we're creating the buffer. C buffer is just that. Show window, why not? Show window here. Sprites, game sprites. Yeah, so this rect screen thing, this is gonna be game screen rect. Screen rect, game assets. Yeah, that works. Sprites pointer, game sprites. Animation is, so this is game assets. Animations elements plus sprite animation ID. Camera position sprite scale multiplier. Okay, so that's gonna not happen here. C buffer storage window dimension, again, not gonna happen here. So if the view is obtained, Then we go in and say mapped. What are we mapping sprites? So this is where we're copying copies sprites. Oops. So this is game sprites, and this is game assets. Yes, so this is actually game screen rect. And this copy buffer is not gonna work this way anymore. Copy buffer, well, it's only gonna work this way for the screen rects, because they're exactly the same. We just map, memcopy, and unmap. Yeah, so this C buffer doesn't do that, actually. Copy sprites, copy screen rects, and then this is copy, I mean, set C buffer. Alright, so you need to map, and at the end you need to unmap. So the thing that we are mapping this time is this constant buffer. Oops. C buffer. And this is not a mem copy. C buffer. C buff is D3DL. Is a C buffer star, so we have to cast it mapped pdata. C buff. Okay, atlas dimension is okay. Well, we basically have to set everything. These four things. Window dimensions is a window width, window height, atlas dimensions, game assets atlas width, game assets atlas height, camera position. Yeah, well, is that even changing? No, but it's in game. Camera. And sprite scale multiplier is in game as well. And then we unmap. Set constant buffers to that. Set constant buffers to that. Sprites length. Okay, draw rects. Well, sprites length now is game sprites length. And these things, that's actually game screen rects. Yes, just destroy C buffer. There we go. Okay, so it crashes somewhere. If only we knew where. Oh no, it doesn't crash. There we go. Alright, so that is working. I guess sprite scale multiplier can be increased. Game to whatever it was, 4.4. Why not? Alright. So what was this? Whole section. So creating the game and then fixing a bunch of stuff associated with that. Okay. Yeah, so we still haven't compressed these things. Maybe I should just do that. Since they're clearly... So that's an instance buffer, so let's move that into VSPS. So we have layout, vShader, pShader, and an instance buffer. That. So now it's just that. And the only difference is that we kind of want to call this in create VSPS. Device size of sprite tracked bind vertex buffer. So we just want to say result instance instance buffer. Yeah, and I guess this is like, well, that's a U64 or I64, whatever. Instance buff size. That's what that is. Instance buffer size. And now we just pass this in. And then we pass that in. That can go away. It's just here. Yeah. So this would be instance buffer. This would be instance buffer. This would be instance buffer. And well, now this is sitting inside of that, so yeah. So it's just this. draw rect. Now this instance buffer comes from VSPS. VSPS instance buffer. RD instance buffer. Okay. A bunch of errors still. Oh yeah. So destroy rect's instance buffer. Actually, yeah, I don't even need that really. I can just call listing that. Just that, and then oh my god, and then inside one of these we can do destroy instance buffer like that. There we go. There we go. Debug console. We're good. Alright. Okay. So I think I've compressed D3, D11 equals. Yeah, I think it's compressed sufficiently. Platform. Okay. Move stuff out of D3, D11. Alright, well, I mean, at this point, I think we can do some things like we have the stamp texture displayed here, and we have the stamp rectangle displayed here. Is there any specific text we want to draw? I mean, we do know we have to be able to draw text, for sure. So I guess maybe I can just do that. Yeah. And that's gonna, well, some text is gonna be like debug text, just, or UI text. That's displayed using like screen coordinates, effectively. Well, debug text especially is gonna be using screen coordinates. UI, not necessarily. Oh well, maybe. Yeah, but well, I guess let's think about text. So I'm just adding okay, so the first one is just the solid colored rectangle. The second one the second one is the text. Well, we almost don't need separate rectangles for each of the glyphs, because each glyph is in its ASCII position and it's the same width. So really, we can kind of work that out ourselves here easily enough. Just before pushing it into the screen rect array. Alright, so that would be something like, well, hold on. Yeah, let's leave this. So if the glyph is A, then you would go rect glyph, well, even like v2 glyph. I mean, it's just the x offset, right? It's either to glyph x offset is glyph, just the ASCII value of the glyph, times like the width of the font, which I guess should be in the assets, game assets font width and glyph width. So that. Now assets don't have a font struct on them, but we can add it. Asset begin struct data b asset end struct font asset add field data b, and then the field is I mean int works with glyph width font. Am I not saving font anywhere? I guess not. Well, let's pull that out here. We do want to save it. So font glyph width. Yeah, we know we're gonna want glyph height and such. Although maybe at this point I should just copy the whole struct. Glyph count. I mean, this gap isn't really, and the texture isn't. No, it's just glyph width and glyph height pretty much. Yeah. We don't really need much else. Glyph height, do we even need glyph height? No, I don't think we do. So that. Is font a pointer? No. Oh, no, this is just pointing out that this failed. Alright, that's okay. Assets, font, glyph width. Generated. Oh. Obviously we want to write out the generated code before compiling the main code. Yeah, that'll help for sure. Yeah. Okay, so that is the glyph x offset, so screen rect glyph rect is was the top left. We have a top left, and right. I mean, we have a lot of things actually. Okay, well, we have a position, which is, well, we have this atlas. Oh, hold on, rect. Let's just do that. top left. Okay, the top left of the rect is atlas. Game assets atlas. No, not even that. It's game assets atlas locations. Atlas ID font there. Atlas location. What's it got? Right. Yeah, there we go. So that is the atlas, the whole atlas. So top left is atlas. Top left x plus glyph x offset. It's just that. And then atlas top left y. The y is the same. And dim is game assets font glyph width, and height is just atlas dim y. Yeah, because the way I packed them, I think I packed the whole atlas, right? Yeah, I think I packed the whole atlas and not individual glyphs. So this will work. Okay, so let's just see. Can we do one of these? Position is like over here. Why not? Dimensions is glyph rect dimensions. Text in atlas is that glyph rect. And color is green. Alright. Interesting. Yeah. So size of that is something else. Presumably like 4 bytes of something else. Yeah, size of data is exactly 4 bytes ahead, which would mean that we didn't write the assets, but we did right here. 36. Yeah, 4. Oh, padding. Should we just say pack 1? Like it probably inserted padding like here. You know, somewhere. Or, yeah, well, yeah, it inserted padding somewhere for sure. Because, like, it didn't like there being no padding. of course, where is the padding is a question to ask. Well, should I not put padding in? Actually, where would it pad it out? Like the way I'm writing it out, I write out this first, and then it inserts 4 bytes of padding somewhere. Int, int. Then, okay, so this is, all of this is 32-bit values. Atlas location is, again, it's 32-bit values, just rectangle is 32-bit value. Okay, so far it's all 32-bit values. This is 32-bit. So it's everything is 32-bit until you get to this point. The first value inside of that is 64. So presumably there's like an odd number or something of, yeah, and that's why it's, if there's an odd number of these 32-bit values, then this pointer will not be aligned to an 8-bit boundary, so that's why it probably inserted some padding here. Maybe. But we don't care about that, we don't care about alignment, we decided, so so wherever we are generating this type def asset data, so begin data, so we're just gonna put pragma, oh god, how do you pack things again? It's such weird syntax. Pragma pack push. Yeah, of course. New line, and then pragma pack 1. Type the abstract asset data, and then to terminate it, it's pragma pack pop. So new line, pragma pack pop, and then 2 more new lines. Alright. That works. Let's see. Okay, that's the build. Yeah, we know build is working. Alright, there it is. Actually, where is the... We're trying to draw something here. So that's not the correct glyph. I mean, it is drawing something though. What is that thing? Is it even in the atlas? Like, what is it drawing? It's probably not in the atlas. Yeah, hold on. I might be confusing my coordinate systems. So glyph x offset, that's in texels. Atlas though gives us, I mean, that is in texels also. No, and it includes the gap, actually. It includes the gap. Yeah, so each glyph, yeah, we need to skip the gap. Ah, so it is correct, kind of. It's just, instead of being here, it's like some distance away from that. You know, whatever, something here somewhere. Um, so let's write out the what was it? Gap, because we have it here, right? Gap width. Gap width, gap width. So now we have the gap available. So the offset is times glyph width plus gap width. Yeah. So, and the gap is 1 pixel. Maybe it should be 2 pixels actually. Well, we'll find out. No, it is 2 pixels. Yeah, it is 2 pixels between each glyph. So that would offset us to the start of the next glyph, except not really, right? So glyph width, this glyph width is the rect that's actually got, that does not include the padding. We have padding. We have padded out everything such that, yeah. Oh, alright, so how are we handling that? I mean, I guess I can supply glyph width and gap width and let the game figure it out. So to draw an individual glyph, you would offset by that much. Would you? Well, a gap of 2. Let's just look in Render Doc at the actual texture getting there. Yeah. Okay, so this is a 1 pixel space at the top there. Yeah, so at the top, for example, we have a 1 pixel space, and at the left here we also have a 1 pixel space. Yeah, of course we don't have actual textile coordinates. No, do we? We do. Okay, so this is at 11. We know that glyph width is 8, so this is like 11, and this is 18. Yeah. Yeah, so this is 1, 0, 0 is the gap, then 1, and 8, this is where it ends, right? And then 9, 10, that's the gap, and then 11. Okay. Okay, so the offset is actually on the border here. So if we jump by 10 pixels, that's from 0 to 10. So that's the width plus the gap. So 10 would be here. That's actually correct. Yeah. And then if you jump by 2 to 2, that'll be 20. 20 is here. So 8 plus 2 is the correct thing to be jumping from the edge of the atlas, which is 0, 0, right? Yeah. Okay, well, That's fine. Now dimension, we need to include the gap, so it actually is +2. Although this is +2 specifically because there is 1 pixel on the right and 1 pixel on the left. Should... That neat coder is raiding with a party of 4. Thanks for the raid. Should I supply the gap or should I assume the gap? Maybe I should assume the gap. Alright, let's not write it out. Now it's correct. Alright. Well, let's draw. Well, so this is drawing glyphs. Draw glyph. What do we need? Font? Well, really just the glyph width. And I guess I could pass the whole game here. Which would mean that I actually need to define that struct. Okay. Game 1. Yeah, that works. Draw glyph. Game A. Well, I mean, I guess I should draw something else. Yeah. Okay, so we can draw a glyph in a fixed location. Yeah, this should probably supply a location. Location. Top left, which is here. Let's draw another one at a different location. Okay, so I think that's enough to draw a string. Void draw static. Excuse me. Draw string. Game str v2 top left. For char index string char index char pointer char index draw glyph game char top left, except that the top left is gonna have to change. v2 current top left current top left x plus equals game font assets font glyph width. That works. Yeah, I'm not calling it. Draw str game test v2 100 300. Right. Point. Okay, well, we can draw strings, why not? So we can draw strings. I guess I should remove the atlas. Now, color. v4 color. Well, red, let's say. Yeah, I mean, that works. That works. Of course, this is drawing strings on screen rather than in terms of like the world space. We also need those. Can we make that happen? Well, I mean, we can by translating wherever the piece of text is supposed to be. Like, it's not really a sprite. And we always know how to translate. So I guess just keep it this way. Like, if I wanted a number to show up here, specifically above this entity, well, that entity is this entity. It's got a position. And let's say we want a number or some kind of string to show up on top of that. Well, let's just see what needs to happen, I guess. We know it's the third sprite, so let's just say sprite sprite is game sprites pointer plus 2. Alright, we know what the position of the sprite is, and we want to know where that is on screen. Now sprites have a position. Okay, what do sprites have again? So they have a position which I'm keeping kind of ambiguous as to what that means. Bottom left, I believe. Okay. Well, I guess we can find out what it means. That first sprite is drawn at 0, 0. I mean, I guess I should omit this. The first sprite is drawn at 0, 0, and it's a commander that's not mirrored, so it's this one. Right, and if we look at that, where's 0.5, 0.5 is what I want to know. Okay, well 0.5 is here. And 0.5, yeah, here. This is 0.5, 0.5. Exactly. So it's the top left. So pause is really the top left of the sprite. I mean, that, why not? Right, that works. Maybe I should just call it top left then. Oh my god, that's fucking... Just rename it, just rename it, like, come on. Yeah, so that pause is used as a top left, pretty much. Yeah. So, does this offer a rename? Nope. Top left. Pause. Yeah, that pause. Yeah, this is also top left. Well, top left dim, that would be erect, right? Script pause, script dim. Well, script pause isn't a thing, actually. No, it's hold on. E.g. script dim. Yeah, what's wrong with that? initializer overrides prior initialization of the subobject. That's it. Oh yes, top left there. Oh boy. Alright, so we've got screen rect. So this is script top left, and this is script dim. Yeah. Screen rect. So this is again this is script pause and script dim. Dot script. No, it's not pause though. Well, actually, I can just do it this way. Yeah. Okay, so sprite common pause. A top left. Okay. So now I just got some errors here to fix. So offset the pause, this is top left. Alright. Okay, so that does work. Seemingly, yeah. What was the point of this whole... So the point was something like, well, I want to draw something on top of a sprite. Although for now, I guess I should commit what I have. That, we've got that, and build, what are we doing? Yeah, just backing. Move the font out. Yeah, okay. So, draw as string. Yeah, and now I want to draw something on top of a sprite. Sprite is games sprite pointer +2. Let's just take that one as an example. Sprite, okay, well, we've got entity top left, x, y. Of course, this is world coordinates. So, I mean, what I kind of want to do is just say this v2 like top left top left would be world to screen. World unit to pixels. Or something like that. World to screen. Yeah. So somehow that translation needs to happen. How? Well, you move it to camera space, right? First. Camera space is sprite minus camera game camera position set. We can't do that. v2 sub. So we subtract the camera position to get to the camera space. This is still in world units. Now we have this scale multiplier, which is essentially just how many screen pixels are there per source pixel. So 2 pixels from center would be camera space. If camera space is 1, then really that's like 4. v2 scale camera space so scale it up by that, and then just well, my 0 needs to move to the top left, and it can't be in the center. So if it's 0, then we add v2 add half dimension window half dim. Is that it? Yeah, if it's minus minus, then you add, you get 0 0. Yeah, I think that's it. v2 window half dim is window width window height. Top left is gonna be screw top left, and color is gonna be green. Okay, so well, world to screen, that's kind of what I'm doing here. I guess I don't have some things. I think that's on common, yeah, add, and there's also a scale by v times by x times by, and y is vy times by. Right. Okay, well, wherever it was drawn, let's see. It's not the right place. Okay. Camera space 20 minus 20. That seems correct. Yeah. Pixels from center. 80 minus 80, except top down, bottom up. y goes down, I mean, y is negative when you go down. Yeah, okay, so y times equals negative 1. To flip the y, eighty from the center. Window have the can I okay. Window have dimension. Oh yeah, because we haven't queried the window size yet. I mean, I guess I should just put this into the update. Temp update. Yeah, well, we kind of do want to know what the window is. Should I query the window before the update? Query the window, then update, then do the thing. Although then it's kind of out of well, it's not going to be resizing much anyway, so whatever. Okay, so that handles animations. That handles input. Here we figure out how long it's been since the app. Okay, so far this is making sense. Did we break somewhere? Oh, we did. Interesting. Yeah, we're not clearing these things. Oh yeah, because that's right. Because I always push them in just before the loop, not in the loop. Well, should they be pushed in the loop or before the loop? I mean, I guess sprites... I mean, the way it's working right now, sprites are going in before the loop, and then screen racks are going in after. I mean, inside. Yeah, well, sure, why not? I could just clear them. I mean, I guess... let's just isolate it here and say that game screen rect's length is 0. Alright. So that... that is being drawn where I expect it to be drawn. So that's good. That part's working. Of course, we can also draw it on top of that first sprite, and then I should move around. Of course, where is our... our zoom? yeah, so it is kind of, there's no blending, so it's kind of teleporting left and right, while the actual sprite is blending. And these world text sprites should probably blend. Just using normal bilinear blending. Unless the text is large, in which case, oh man. Okay, and this is something to think about. How should text, how should strings behave when they are tied to in-game entities? Okay. So right now it's not clear exactly what should happen to them. Well, this is what we have. Alright, well, this is all for today. Thanks everyone.